This video was supposed to be so easy. It was supposed to be, hey, this is a piece of tungsten tubelite, here's what it looks like inside, and that was it. But it went off on a wild tangent. It's been a great evening. I've really enjoyed it. It's now 2 AM, it's actually after 2 AM, and I think it's time I actually made the video. So, let's start. This is LED tubelite. It's the more modern version of tubelite. It goes under various names. Some people call it ropelight. Traditionally, ropelight would have actually been a hollow sort of hose with tungsten lights inside it, or even LEDs. But this is it goes under various names. And typically speaking, Christmas lights will, particularly the municipal ones, will have an aluminium frame like this. This is a flat strip that's been shaped, and it will have the tubelite on it. And these aluminium frames will initially be welded onto a larger structure, and then the tubelite outline will be put on, and it just provides a very easy way of providing a nice silhouette of light that surrounds the outline. It makes it light up as a pattern. It's very nice. And the history of this is quite interesting because, and here comes exhibit number 1. Let's adjust that down so you can actually see that. This is a patent for tubelite, the very first one, and it goes back to 1986. And the guy that invented it was, well, the guy that certainly applied for the patent was called Tai-Ye Lin. And back then it was called non-neon because he presented it as an alternative to neon, and obviously that's not the case because nothing replaces neon. If you want neon, get neon because nothing matches the linear shape of neon. However, this was presented as a nice alternative, that it was a tube that you could basically shape round borders and things like that, and it could be put in by anybody, and it was cheaper than neon, not that much cheaper than neon. It was actually really expensive at the beginning because it was considered as an architectural medium. And the first version was based on screw-together connectors, which was later changed to just everything glued together laterally for the outdoor stuff. But the idea was you had a plastic core with the tungsten lamps pressed into large holes in it, and then the leads put down smaller holes, and then metal shorting pins put in. And laterally, that was changed quite quickly to, so these lamps were up the other way. So the leads actually came down the sides of the lamps, and that meant that when you flex the tube, it didn't put so much stress on the pinch seal of the lamp itself, and because up to that point it was quite fragile. And it had these connectors that joined together with basically, well, this is actually a piece of non-neon. This is the original non-neon. And I have this because it's from George Square, the George Square Christmas lights. And the reason the very first piece of this material is from George Square Christmas lights is because the George Square Christmas lights in Glasgow were the first ever silhouette Christmas lights to use tubelite. That is quite significant. It's really significant because it created such a sensation at the time that it was widely copied and gave birth to the current generation of Christmas lights. You know, silhouettes would probably not have existed in this form if George Square hadn't happened in that style. And I'll talk about that afterwards. But the main thing is let's take a look at the tubelite first. We've got this, it's got this core inside, and I've already cut a piece off this. Sacrilege, because it really is vintage stuff, this. So it's got the outer coloured plastic core, it's got the white core, it's supposed to be clear but the colour has sort of permeated in, and it's got the large holes, and it's got the small holes, and it's got the tiny little shorting pins, and it's got the little lamps. Now you're not going to see that because it's far too small, so let's bring in exhibit number 2, which is a large photo taken of it. I'll put that tubelite down there. So let's clear this off a bit. And ironically, look at the shape of the pin in the patent and the actual shape of the pin here. It is identical. It's that slightly knurled pin with the point. And the lamps, as I say, they went into these large holes, but they went with the wire ends down. And then the wires were taken across and tucked down, and these pins were put in to short them out. And that way they created long series runs over the course of whatever the distance was. In our case, it was 240 volts. It was 1 metre that you could cut it. And where it connected to the end, it also had these little bus bar wires running inside. It was done as a double moulding system whereby they initially moulded the inner core with all these holes in it. It must have been quite complex. But with these wires running down the middle. At either side, well, I say the middle, either side anyway. And these are the main bus bar wires that fed all the lights. And when you come to a point that the string of LEDs is connecting across, then it's clear that, you know, a thin multicore has been of strands of wire have been inserted into this through the insulation, taken across to a pin, and then that shunts. But when the pin's put in, it shunts it onto the string of lights, and at the cut point, you'd have one of those either side going to either side of the bus bar, and that would be the start of a complete string of lights. And this was originally sold as being indestructible, as the sales industry does. They said, you know, lasts forever. Super low power. It was about 16 watts a metre back then. And it's indestructible. And rather importantly, they said, and this was the annoying bit, these connectors are waterproof. They're really not. Seriously. Not in Scottish weather, they frickin' well weren't. So, standard construction, it's got this little connector which has the sharp serrated pins on that side, quite wobbly actually, going into what we called a biscuit, the little disc which is a slightly off-centre, which I'm guessing it was just to facilitate the manufacture. They could have put it central, but it is off-centre on that. That's quite essential in the LED stuff in a way. And all the information on this you got was, well, it says 210 in this. I'm not sure if that's the voltage rating. Certainly everything was run slightly nudged down. All this stuff in George Square was run on a dimmer system, and it was nudged back slightly to accommodate that. But all you had was, the only printing on this was like that number and then a tiny little mark. That was it, and that's where you cut it. And you fed on this sort of lock ring, and then you put on this connector bit over that little biscuit, and then because this is tapered, as you tightened it up, it gripped down tightly onto the tubelight and it stopped it slipping out. And likewise at this side, the matching part had a socket assembly, completely different from what we have now. The joining bit now is actually just two of the serrated pin type arrangements on either side of the biscuit. Much simpler, but this was, keep in mind, this was the first stuff. This was the very earliest tubelight. So it had the socket bit, then you sat this over, put on the locking outer nut thing, then sort of gripped that like a collet and gripped it onto the plastic. And as I say, this was presented as being waterproof, and it really wasn't. That was initially a major problem in George Square, because these connectors burnt up all the time. It was a major problem at the beginning, and initially we wrapped them, which is a bit of a shame. We wrapped them in black insulation tape to try and, because it was what we also used for blacking out bits that weren't to be seen. That also covered some of the lamps that were visible at the end. And latterly we switched to using black rubber amalgamating tape. It was the only way to make them really waterproof. And latterly again, the materials moved on and they got rid of these joining connectors because they were just a nightmare. They were a disaster. They were maybe ideal for indoor use, but they most certainly weren't useful for outdoor use. So the history of George Square comes down to a chap, largely a chap called Harry Tegan. The history of Christmas lights made of this stuff basically comes down to Harry. He might not even realise it, because it's only when I'm looking back now that I realised, oh my god, that's just ridiculous. That's how it all started, because this was patented in 1986, and not long after that it was presented as an architectural material. Harry Tegan was an architect who worked for Glasgow District Council, and he was very, very eccentric, slightly scary, eccentric, very, very weird, but very likeable. Had this strange tendency that whatever he was in his mind, he just said it, and if he didn't like you, well, he told you, and fortunately he liked me, which was good. Because other co-workers didn't like him, he just told them exactly what he thought. It was very odd, but funny at the same time. And Harry was just, when he got his teeth into a project, he just went full tilt, and he got the job of doing the George Square Christmas lights in Glasgow. And he absolutely, keep in mind that this stuff had not been used. It had been shown that it could be formed into shapes and silhouettes for indoor sort of like neon signs like that. I don't think MD had ever considered using it outdoors in Christmas lights, and the George Square Christmas lights were the first of their type. They were the first silhouette Christmas lights with the tube light on them. And as a result, it was a bit of a learning curve for everybody, including Harry and us and the company that makes the non-neon. And because they didn't exist back then, all the existing Christmas lights that have now just been removed from George Square, they were the prototypes for the entire silhouette Christmas lighting industry. Everything now, including the new lights that have been put up in George Square, owe their history to the original lights in George Square, the bells, the hollies, the angels, the stars, everything, because they were the prototypes, and that's why they were made of steel as well. They were heavy. Christmas lights at that time, well, the Christmas lights before this came on the scene had been, in the case of George Square, it was Blackpool decoration, hand-me-downs. They'd bought them from Blackpool, which is like... Blackpool is Britain's equivalent to Las Vegas. It's a sort of, except it's a seaside resort, but it's majorly famous for its illuminations, and they are spectacular. And before this came along, Glasgow Council's guys used to install a major Christmas lighting display of all ground-mounted stuff, big, huge three-dimensional structures that lit up with basically just screw-in lamps and fiberglass panels with lights behind them. It looked fantastic. They did a great job. But this was just setting a new ground, and it looked so futuristic at the time. Harry just went to town on this, and to give you an idea, he made another gallery exhibit. He designed these bells, which are three-dimensional bells. You think, oh, bells, what's so special about, illuminated bells? They were the first ones. They were the first illuminated bells with tubelight. They were the first illuminated holly with tubelight. And because like it had never been done before, they used what materials were available. It was steel, and it was three-dimensional steel and everything, because nobody had ever done it before. We didn't know how the wind loading would affect it. Everything was just geared up to extra strength, and they weighed a ton. It was a back-breaking job putting them up. And he also came up with the idea of putting huge steel angels on top of the poles. Now, this is an Alamy stock photo, and I've not asked permission to actually use this, but I don't have any problems with that, because it's an Alamy stock photo of me bolting one of those angels onto the pole, and I don't remember being asked, by the photographer if he could take my photo and then start making money out of it. So, yes. So, anyway, that's me putting one of the angels up to give him scale. The angels were not tubelight, the bells were tubelight. That's the original tungsten version at that time. I think at that point we'd switched to LED hollies. But these angels were all wire frame, but again they were steel, very heavy 4-man lift. Everything had to be craned into position, and they were lit initially with 400 watt ultraviolet floodlights, 2 of them underneath, and they were painted with day glow paint. It looked so weird. During the day, you looked up and it looked like there were these weird 3-dimensional iridescent angels on top of the poles. At night time they lit up in these day-glow ultraviolet colours, and it looked like they were hovering in the air. It was a fantastic effect. They're also gone, sadly. So the bells were made, because nothing like this had been done before. They were all custom made by welders and artists and blacksmiths in Glasgow, male and female welders notably, because Glasgow had a huge engineering environment. It had an industry of shipbuilding and stuff like that, so there was no shortage of skilled welders. And likewise, all the hanging effects down the poles, which some of them were done with tubelight and some of them were done with tungsten, and they were all custom made. It was just one-offs. Every pole was different, and because Northern Light was involved at the beginning, Harry had this vision that everything would be animated. It would be a huge Blackpool spectacular. It would be literally what they call a Christmas lighting spectacular. And as a result of that, there were 200 channels of animation, and it was all controlled by banks and banks of strand dimmers, controlled by whatever flavour of strand lighting desk was available at the time. And it was really heavily animated. At the moment, if you look at this picture, you see these catenary wires with these effects hanging on them. There was also, and they've not been used since, another set of catenaries down below. The eyes are still there for them for the shackles to go onto, but there was also another complete set of decorations hung below, plus all the hanging effects. It was just a complete chock-a-block with animation. It was weird. It was like something out of Blade Runner or Gotham City. It was just fantastic. And the strange thing is, like, I worked with these lights for over 20 years, and I didn't realise at the time that it was pretty much breaking new ground at the time. This stuff cost £15 a metre back then, and keep in mind this is back late 1980s. That would have been a fortune then. It was certainly, when I was putting it on, I was like, just like handling it with kid gloves because it was so expensive, and the amount that failed initially was just like, you're thinking, God, this is costing a fortune. But latterly, you know, nowadays, if you paid £2 or £3 a metre, that would seem expensive. But back then it was so radically new. It was architectural material. So now it's ironic that the last time I did the George Square Christmas lights was 2013. At that point, 2014, I couldn't do it. My mum was needing too much attention. My brother couldn't deal with looking after himself, so I had to move across and spent a lot of time looking after him. So it broke my heart at the time. I just loved the George Square job, but I couldn't do it in 2014. And I'm not sure what happened, but Northern Light was bought over by another company, and I'm not sure if that was connected. But in 2015, another company took over the Christmas lights in George Square, and they must have been cursing when they put the original lights up, because if they were used, it's actually a company that their main business is putting up tents in fields for sporting events and weddings and things like that, but they branched out into Christmas lighting just to fill those dark winter months when there are less events outside. And they tend to deal with the standard municipal aluminium frames, and they must have just been I'm not sure what must have been going through their minds when they had to install that stuff. They must have thought, what the heck is this? Who made them out of steel? Well, the reason they were made out of steel is because they were the prototypes. And they did that job 1 year, and then this year they put up all new flat aluminium frames in cold white and warm white, and that's it. No animation, just static aluminium frames. Which, it's odd. I was over earlier this year and I saw it and I thought, it's nice, but it's really odd. After what was there before, after the Las Vegas style spectacular of animation that was there before, which had gradually dwindled over the years, it just seems so strange to see such a plain and static display. But they must have been thinking, you know, why did we use the steel frames? And ultimately it's because they were the first. And ironically, the frames they've put up now owe their origin to the George Square lights, because the George Square Christmas installation was so spectacular at the time, it was so radical because it was the first to use this non-neon tubelight, that it made headlines all around the world. People actually travelled from other cities in the world to look at the George Square lights, take notes, take photos, and it was widely copied. A lot, you know, the whole industry, this aluminium frame owes its origins to the George Square Christmas lights, because they set the trend. They established a new market of this tube light being used in Christmas lights. So it's pretty, you know, I didn't really fully twig that before. And it's just now that I'm realising that that is the situation. And I've been checking up and talking to people, and it's like, just makes me realise this was such a historic installation. You know, these bells literally are, I don't know what's happened now, I'm guessing they've been scrapped, but all these effects were the first of their type. They set that new trend, which is quite impressive. And at the beginning they had their own dedicated warehouse. It was where was it? It was a warehouse in Glasgow, an industrial estate. I'm trying to remember the name of the industrial estate. It's named after one of the Queen's houses. I can't remember. Nope, can't remember that estate. But it was a dedicated warehouse, and all the effects were just sat down. It was important because it meant all the bells just sat down the ground and you could walk amongst them and work in them, because they required a lot of maintenance, because the heavy steel took its toll on the material. The aluminium is a lot better that way. But latterly, due to penny pinching, ultimately they kept moving the Christmas lights into smaller and smaller storage areas, and they invented ways to stack them, and they ended up, it just crushed the tube light. It caused so much damage that there was so much maintenance involved that maybe it's a good thing that they've been replaced now with flat, lightweight aluminium frames. But certainly, at the time, with their dedicated warehouse, for the scale of the display, it justified having their own sort of storage area. So that's it. Ultimately, that's it. Started off just a simple video about tubelight and made me realise just how involved I was in the history of the use of tubelight in Christmas lighting and how it's evolved. So I'm going to do another video on the LED tubelight, and I'll take some of that apart as well. I'm not sure what the way modern tubelights constructed the LED tubelight. Certainly the stuff we've got, the stuff that we first started using, the first replacement for the tungsten stuff is this. And it's a completely different construction. It's got a hollow channel inside, and the LEDs are all, it's almost like they've been manually assembled, like a string of series lights with resistors, and then they've been pressed into that channel. And I was talking to someone who had custom lights manufactured, and he went to China to see it all being done. And he said there was a production line with women, all the full length of the production line, all they were doing all day was pressing the LEDs into this channel. What a tedious job. I wonder if they've, I mean, technically speaking, with the flat strip these days, it's easier with the circuit board. But the problem with the flat strip is not three-dimensional. With these, the LEDs can be viewed all the way around. The only thing that really blocks it is the bus bar wires, but they don't block it that much. The light still gets round. With this stuff, it is very directional. So it's not as easy to manufacture. So I'm going to have to buy myself some generic LED tubelights, some of the more modern stuff, and see what its construction's like. But there you go. The tungsten tubelight, its first application in Christmas lights, the patent, and all the pitfalls that we had to iron out, and ultimately the Christmas lighting industry has benefited from what we found out the hard way. There's some other bits I wanted to add to this video. One of them is how the control system was arranged. It was actually a D54 network. D54, you can look that up if you want. D54 predated DMX. We later moved to DMX when the D54 got a bit flaky and it was hard getting dimmers that dealt with that. The D54 was what's called a multiplexed analog protocol. Instead of sending data bits, it actually sent a stream of analog voltage levels representing sort of 0 to 10 volt, the dimmer level between 0 to 100%. And it also sent some synchronization pulses. So ultimately, its biggest weakness laterally was that when all the dimmers started getting a bit old that dealt with that, and we started getting just dodgy, dirty connectors and stuff like that, it meant that whole sections of the screw would just gently flicker up and down with bad connections, which was a bit annoying. So we ended up switching to DMX and buffering it up thoroughly. Other things worth noting that were quite radical at the time, but probably not a good idea. Harry Tegan, we had particularly one particular effect was a sort of, I'll just try and draw a sort of silhouette of it. Imagine it was based on peacocks. Oh, this is going to be a terrible picture of peacocks. No, that is a terrible picture of peacocks. But basically speaking, it was these birds with the big plumes coming out their tails, and it was all done in multiple layers of steel frames, and it cascaded, and the animation was such that, you know, the plumes all built up and fan backwards and forwards. A very good effect, but Harry was experimenting with tubelight at that point in time, and we did it all in clear tubelight, and then once we'd put all the tubelight in the frames, Harry came in the evening and painted the tubelight with glass paints. So he painted it with all sorts of like greens and purples, and he tried to make it look as close to the plume of the peacock. I'll just draw a wee foot. Is that peacockish? Yeah, that's like peacockish, and it's a happy peacock. No, it's had drugs. So the frames that he painted them, but unfortunately, because it's plastic and because he used glass paints that had solvents in them, the paint never set. Every time we put that frame up, and keep in mind that it was all done in frames, and for continuity, we actually every year we had to actually unroll sections. We had to untie sections of the tubelight and actually take it down and coil it up from the upper frames of section effect. But the paint just never cured. So when you've been working those lights, your hands would just be covered in sticky paint. It was just, it was horrible. Other things worthy of mention. Oh, the connecting system. For a start, because the tubelight was presented as double insulated, modern frames would have an earth on them. And these original frames didn't. So instead, where it actually reached the pole, each side of the square had a really heavy earth cable going out with a bond onto the pole, and then bonds onto the catenary wires. And the catenary wires, it was just a sort of as a precaution, because the weight of the decoration itself, which weighed a ton, sort of bit onto the ropes. The steel ropes had to be changed every so often. Part of our job was every year we'd check the ropes, and if we every certain number of years we'd take it out, we'd completely de-loom one of the ropes, and we'd take the steel rope down, we'd send it away for destructive testing, get the replacement back all punched with the numbers and ratings, and we'd put it back to replace the others. So there was an ongoing replacement of the steel ropes. Probably less critical now that it's aluminium frames because there's less of a weight loading. The steel poles themselves, actually let's get the connectors, because again it was the dawn of the industry. They wanted the minimum amount of cabling on the catenary wires. They didn't want huge big junction boxes, so we had basically multi-core with the cables, the cores coming out, and they were fanned out into initially little 2-pole connectors, and then they were sleeved and then taped up. A bit ugly, but you know, it did the job. They just didn't want too much stuff visible on the catenaries. Latterly I changed it to C-form connectors, which is a sort of a ruggedized industrial connector, but it was never ideal. What I really wanted in that job was a small junction box and then a fan out of connectors suitable for that, or even a multi-pole connector. It's just, I never got what I wanted. They weren't terribly adventurous that way. Now I've suddenly realised there's another bit I want to show you, but I'll show you that as an extra bit of video after this one. So initially we used these little lawnmower style connectors. Keep in mind, this was the dawn of this in the industry, which had they were the little domino connectors used for outdoor garden appliances. I'm not sure why they used them. But you know what? I have to say, they provided stellar service. It was they lasted a long time before I needed change. The only niggle I had about those was they were tingle-tastic when you parted them. When it was raining and you were going up to fix lights and the local means of isolation was to pull those apart, oh yes, that was thrilling. That was evidence that cherry pickers, despite the fact they've got rubber tyres, particularly in the wet, they're very conductive. Yeah, even wet gloves wasn't much help there, but then again, this is the curse of outdoor electrics. So the little domino connectors, they had this trait that because there was a 3-pole version available as well, and because these things only had the 2 cores coming from the tubelight, it was the 2-pole version that was used, and the middle pole was just an empty hole, which was kind of good because it meant that when the water inevitably got in, it just drained out. These were actually real reliable. I mean, I wouldn't recommend their use these days. I'd always recommend something like C-form or a proper waterproof connector now. But at the time, that's what they had, and it was only quite late on. I can only recall one that really failed, burnt out to the point that it caused a short. All the other ones, the main problems and the point that I eventually decided to change them was when they physically welded together. It just started happening when the pins got so corroded that as time went on, with the heavy load of the tubelight, which at the peak in George Square, we had 3 sides to the display, and it was roughly 100 amps a phase either, on all sides. It was a huge load initially because of the sheer mass of the lights. But that was changed latterly. While the guys were repairing the stuff up at Balmore is the place that we stored them, and latterly, I think it was when they were still at Balmore at that point, the good storage space. It was a warehouse facility that had been kitted up so that all the angels sat in brackets in the wall, all the hollies sat in their own brackets in the wall, and the bells are all spaced out. It was all designed to accommodate the bells and allow construction of new effects and maintenance of effects. It was just really great to premises. It was really annoying when that was lost. It was probably financially motivated. Another thing, the poles. when they were put in, they had a 10-year guarantee. They ended up, the display lasted the best part of 30 years. It's like 25 to 30 years, something, I'm not sure. It was a long time. I don't see any modern aluminium display lasting quite as long, but because the steel decorations were just indestructible. But these poles, we were told that under no circumstances were we to put metal banding onto them, because traditionally if you had a pole, let's go on to another page, if you had a pole like a lamp post and you're putting an electrical box in it, you'd have a bracket, you'd put maybe a metal or plastic box on, you'd have a bracket in the back, and then you'd put banding round to strap it onto the pole. We're told under no circumstances were we to ever put metal around those poles, because I think it avoided the warranty or something like that. So we used plastic boxes, and initially it was the pole. And when I arrived in the scene, I wasn't there for the initial installation, but when I arrived in the scene, it was like cable ties, big, thick cable ties, lots of them, strapping those boxes on, then all the cables coming out the glands in the bottom, and then going into the sort of like the main port where the cables came up the pole, or along the catenaries. And latterly, because every time you needed access to the box, because the stuff in the square, every single year, they changed their mind and they decided, let's move that effect over there. And every year, everything had been shuffled. And all the circuits had to be shuffled and changed. It was like a major task every year. But it meant you had to keep taking the covers off these boxes. And latterly, my colleague Gordon said, screw this. And he drilled a hole in the side of the box and put the cable tie round the pole and through that hole in the box. And it looks so rough. Because inside the box, you had basically the cable tie going through the middle. And because it was just standard terminal block for all the multi-cores back then. And you know what? We ended up cable tying the cores onto that, so everything was kept away from anywhere it could get wet. Over the course of the whole installation, over the course of that whole era of Christmas lighting, we never ever had a problem with these boxes. There were drainage holes at the bottom because water was inevitably going to get in there, and they just never gave a problem. At all. Latterly, Glasgow Council up on the top of the poles did mount metal boxes up, and I remember them asking, could you go and take a look at those? It was for their floodlighting for the statues, and they'd have problems with them, and I opened one and was instantly just water just poured out everywhere because it was just full to the brim with water. So in a way that may have looked rather crappy, but it was really functional and it lasted so long, and as I say, it meant that, it fulfilled the rule of not having metal banding onto the poles. I think their main concern was that if we were to get trapped down brackets, between this banding, it could actually cause local corrosion. I'm not sure if it was because of the steel that they were made of. I don't know. I don't know why they had that rule. They had all sorts of strange things. Now, the other thing, I did try, Harry Tegan, when he retired, his successor was not as adventurous. Sorry, John. He just wasn't adventurous. He got in some stock effects for the poles, namely, he replaced some of the traditional effects in the poles with some panels from a company called Blachère, which were just basically LED light curtains with stars. Now, they were actually pretty reliable because initially there were 24-volt transformers and the strings of red LEDs, and they look really nice, red LEDs, and the stars themselves were mains voltage tubelight. Then Blachère one year came out and retubed and restrung them all, and they were just a dog after that. The guys came out, they didn't make things properly waterproof, they didn't terminate them properly, it was a nightmare. They just turned in, from being a really reliable effect, they turned into an unreliable effect. It was not a good result. But I'm going to go and get something else now. Excuse me one moment, I'm just going to go and grab it. Okay, next exhibit. This is one of a set of 8 panels I designed, and I've put a date in the back of them. Actually, it's marked 11/4/2003, George Square Tile Effects. This was an attempt to encourage Harry Tegan's successor to build new effects. And this was going to be a series of vertical hang panels, and heavily animated. I even took in a Fairground Light Controller to animate them, so it was really complex patterns that were moving, continually changing on. And this would have been 4 vertical panels either side the pole. It would have looked great, but he just wasn't interested in progress at all, sadly. But that's what happens. Now, there's a few effects that are worthy of mention on George Square, because some of them are just weird and some of them are scary. If you look up pictures of the old George Square Christmas lights, take a look for the Jack-in-the-Box. It normally shared a pole with the drummer. And the Jack-in-the-Box, we used to call it Satan, because that's exactly what it looked like. I'm not sure. I think Harry was deliberately going for old-fashioned sort of visual effects and weirdness. But the Jack-in-the-Box just looks sinister, but it's good for that. It's the Gotham City twist. It's quite good to have Christmas lights that are just, instead of the usual cliched angels and things like that, this one had real character. It doesn't help that when we refurbished it, we had so many problems that laterally with the festoon, particularly the Italian caps that were in the festoon that kind of defeated its waterproofness, which wasn't a good idea, that we retubed it in tubelight. And since we already referred it as Satan, out of a moment of naughtiness, we coloured its face. We used green tubelight for the face with red eyes, and thereafter referred to it as Satan. Another thing to look for on George Square is one of the favourite effects. It was a stocking, and you look at it and think, who the fuck designed that? It looks so shit. It's not. You look at it, it's a stocking full of toys, and it looks really abstract and weird. The reason is it was designed by kids. It was designed by kids. As far as I know, I think they were in a hospice. And they were just asked. We said, get some kids design. The Christmas lights are for the kids anyway. That's why we put as much colour into the square as possible. So that whole effect, all the kids designed one effect each, and then we reinterpreted it into the tubelight. And that's why it looks just slightly psychedelic and weird. You'll find that if you look online. You'll find pictures of that. Look for the stocking with all the characters in it, including a sort of Teletubby-ish type character and a clown and a clock, all very weird, but that was one of my favourites. It was also quite heavily animated. It sort of built up to the bottom and then emptied and built up again. Good stuff. But then, yeah, another thing, I got some friends who are artists to come up with ideas for including sort of based in a sense on the original on the tree, the Glasgow tree effect, which I really liked on George Square. It was the foliage with all the sort of leaves, and it was a sort of basically a paisley pattern effect, but it was also going to be heavily animated. But again, there was never a budget. Every year we got the same story that it was the last year of the Christmas lights, they were taking the poles away, and they just never spent anything on upgrading them. So that was kind of the death of the George Square Christmas lights in their original form. Yeah, interesting times though. I don't regret those years. I really enjoyed doing that job.